3.2 Using laws of exponents. If we look at some examples here, we're seeing these terms being multiplied that are raised to powers. We also see powers being raised to powers. When you have multiplication with these variables that have coefficients and exponents, you are adding these exponents and multiplying the coefficients. If you have a power that's raised to a power, you're multiplying those two powers. You need to be careful because when a power is raised to a power, that power is not only to that exponent, but it's also to the coefficient of the variable as well. If we look at example 1a, we have negative 3x squared y cubed times 4xy squared. If we remember from the section before this, that x with the y squared has an invisible exponent of 1. So we have to remember that when we're combining those exponents for the variable x. With this, you are going to multiply the 3 and the 4. So the negative 3 times 4 is 12. Then you have the x squared times the x, which is x squared plus the first. Then you have the y cubed times the y squared, so that's y cubed plus squared. Now you just combine those 2 plus 1 and the 3 plus 2. So this is going to be, this is negative 12. This is going to be negative 12x cubed y to the 5th power. If we look at example B, we have st to the 4th power cubed. So this cubed is getting distributed, so to say, to that 4 and to that s. Remember, this s is raised to the power of 1, so we're going to multiply it by the 3. This t is raised to the power of 4, so we're going to multiply that by 3 as well. So this is going to give us s to the 3rd power times t to the 12th power. If we look at C, we have negative x cubed squared. So again, this is what I was talking about, when it's not only the exponent that 2 gets multiplied by, but it also gets distributed to that negative. So this is like saying negative 1 times x cubed, and this is all being squared. So when you take this, and the squared goes to the 3 as well as the negative 1. So this is going to be negative 1 squared times x cubed squared. So we have to do the negative 1 squared, which is positive 1, times the x cubed squared, which is x to the 6th power. And 1 times x to the 6th power is just x to the 6th power. You have to remember with those that coefficient gets the exponent as well. If we look at our next set of examples, we now have multiplication within these exponents, where these powers being raised to powers. So for example A, you have u times u squared cubed times u to the 5th power. So we have to simplify this using your order of operations. So we're going to work with the middle first. That 3 times 2, so u to the 2nd times the 3rd, you have to do first. So this 2 times 3 gives us 6, so we have u to the 1st times u to the 6th times u to the 5th. So now we're going to keep that u, because they're all like terms. We're multiplying them, and we're going to add the 1, the 6, and the 5 to get u to the 12th power. If we look at B, we have 3xy squared z cubed, all raised to the 3rd power. So again, this 3 as the power on the outside of the parentheses is going to go to the z cubed. It's going to go to the y squared. It's going to go to the x, which is raised to the power of 1. And it's also going to go to that 3. So we're going to have 3 cubed times x to the 1st power cubed times y to the 2nd power cubed times z cubed raised to the 3rd power. So from here, that 3 cubed is 27. The x to the 1st power raised to the 3rd power, multiply these two, that's x to the 3rd. The y squared raised to the 3rd power, multiply them, it's going to become y to the 6th power. And that z cubed raised to the 3rd power, multiply them, is z to the 9th. So if we put this all together, we have 27 x cubed y to the 6th power z to the 9th power. For example 3, we are distributing. When we are distributing this, we are literally taking everything and multiplying it. So we're applying all of our rules here. So for A, we have 3t squared times t cubed minus 2t squared plus t minus 4. So we're literally going to do 3t squared times t cubed plus, because that 3t squared is positive, 3t squared times negative 2t cubed, squared, plus 3t squared times t, and then plus 3t squared times negative 4. So start from the beginning, the 3t squared times t to the third power. We're going to keep the 3, keep the t, add your exponents. 2 plus 3 is 5. Then we have the 3t squared times negative 2t squared. The 3 times negative 2 is going to give you a negative 6. Keep the t, add your exponents. 2 plus 2 is 4, so that's negative 6t to the fourth power. For 3t squared times t, you keep the positive 3, keep the t, and then add your exponents. 2 plus 1 gives us 3. And then lastly, you have the 3t squared times negative 4. So 3 times negative 4 is negative 12. Keep the t squared because there's no other t. So we have 3t to the fifth power minus 6t to the fourth power plus 3t cubed minus 12t squared. For example B, we have 5x to the fourth power times x cubed minus 3x squared y squared plus 5xy cubed minus 2y squared. So again, we're going to distribute this 5x to the fourth power, multiplying those coefficients, adding those exponents. So we're going to have 5x to the fourth power times x cubed plus 5x to the fourth power times negative 3x squared y squared plus 5x to the fourth power times 5x y cubed plus 5x to the fourth power times negative 2y squared. All right, so now we multiply these. We have the 5x to the fourth power times x to the third power. Our only coefficients are 5 and 1, so 5 times 1 is 5. Keep the x. 4 plus 3 is 7. Then you have the negative 5x to the fourth power times positive 5x to the fourth power times negative 3x squared y squared. So 5 times negative 3 is negative 15. Keep the x, add your exponents, which are 2 and 4, which gives us 6, and then drop down the y to the second power. For the 5x to the fourth power times 5xy cubed, we're going to have 25, positive 25. Keep the x. The 4 plus the 1 is 5. Keep the y to the third. Then we have the 5x to the fourth power times negative 2y squared. So that's negative 10x to the fourth y squared. So you see that if there's no variable that matches with the other, so like if there's an x and a y that you're multiplying, you're going to keep both the x to the whatever power and the y to the whatever power. If we look at example 4, for a, we have a squared raised to the k power times a k raised to the third power. So this k is going to multiply by this 2, this 3 is going to multiply by the k. So we're going to have a to the 2k times a to the 3k. Now these are like terms, so you're going to add them. So keep the a, add the 2k plus the 3k. And this is going to give us a to the 5k power. For b, we have x to the power of m minus n times x to the power of m plus n plus x to the power of n. So we are going to distribute this x to the power of m minus n. Remember, when you're doing this, you are adding those powers. So we have x to the m minus n plus m plus n, as well as x to the power of m minus n plus n. So combine your like terms in those exponents. So keep the x. The m plus m is 2m. The negative m plus n cancels out. From there, keep the x, do the same thing. The m doesn't add up with another m, so drop it down or leave it. And then the negative n plus n cancels out. So you now have x to the power of 2m plus x to the power of m. We're going to keep the x, add the exponents. So x to the power of 2m plus m is x to the 3m.